state of it and write to it
HTML, HTTP, whatever, it doesn't matter.
and this is one.
Now, we'll go to a machine that's got opportunistic running, okay? Watch closely these two windows, because that's where you'll see the IPsec connection open up. I know it looks like garbage, but sorry, it's what the tech does. Okay, you can see it initiating. Well, it's all, by the time I turned around, it was done, right? Okay, so you can see it initiating the connection. It says state, quick, and all that. That means IPsec came up. That was the difference in speed. The well was in the clear, and this site was encrypted. Did anyone notice the difference? Not much. Matter of fact, it looks a lot like the net looks at like 7:30 p.m. on the West Coast. You'll also notice that the text down here is really bothering you behind me. You can't see anything that's readable. Okay, this is the proof. This should have been in the clear. Matter of fact, I can replicate that by saying IPsec, setup, stop, stop. So we stop both of those. We go here and type Control-R, and there it is in the clear. That's opportunistic. You set it up on the machine once, you get the text record in, and it just happens. Sir, can you stand up and enunciate? You have complete control of how long security associations, as they're called, last. By default, I think we've got them lasting 8 hours. So that if you open up one connection, it'll last for 8 hours. Let me warn you something. There's a big challenge to the networking Linux community. With this model of communications, the concept of default route goes away. Your routing tables end up looking much bigger. The reason is that you can't have a default route going to the next machine out towards the net. The default route has to go into the thing that decides, are we going to do opportunistic or not, right? And then what happens is if it decides not, it has to make a clear route that is kind of like the old default route, but it's specific for the machine you're trying to talk to and the machine you're talking from, all right? Or it makes an encrypted route between that pair of machines. So routing tables are going to get bigger. They're going to be much more dynamic. Things are going to be coming and going all the time from the daemons. It's critical that the daemons live. It's called details. Do you have a follow-on?
Yeah.
Please.
Basically, with each of those security applications, a new route pops up and disappears.
Yeah. Would you like me to show you that?
No, it was just make sure.
Yeah. The routes pop up for a certain amount of time that you set. So right now the default is something like 8 hours, right? So if the second connection or the second person on your subnet that's trying to talk to the web server, it just goes across instantaneously encrypted, right? There's also optimizations we're working. We're going to store the first packet or NK worth of packets, and then once we decide if we're in the clear or not, we'll release those packets, and that will speed things up because when we talk to Sun's set, in encrypted, it lost the initial packet, and you also had to go through a TCP timeout. 10 minutes. Okay, well, I'm done with the presentation. I want to eat up these questions. Let's go forward to back. You in the red, and you in the black. Stand. Oh, you're not asking a question. You're just stretching. You in the black.
Okay, one question.
Stand up and enunciate. There's a whole room full of people that want to hear you.
You have to breathe first, okay?
Well, don't breathe in the smoke.
Now, one question. The current installed, my freeze one, has a limit of 4 connections.
No.
4 times.
No.
I'm completely wrong at the moment.
Right. No, what you're seeing there is the current FreeSwan has a artificially low limit that could be raised of talking simultaneously on 4 different devices. IPsec 0, 1, 2, or 3. Right? That means that you can have 4 devices that go toward the outside world that you might run in an encrypted tunnel over. That number can be raised. The man sitting with the hat next to you in the light is the sucker that you can ask about how to raise that. And, unlike me, you can talk to him anytime about crypto. You can talk to me anytime too, but not always about crypto. So he can answer those questions, how to deal with that. The number of connections is essentially limitless. If you see, a couple thousand old routes that haven't been used in a few hours in your routing tables, you probably want to lower how long a route lives before you reap it and have to rebuild the connection. But you notice how quickly these connections build, right? Even with opportunistic, where you're going out and requesting this TXT record, it's hard to tell that from normal delay here at camp, and we've got a good link.
Excuse me, is there a test site Excuse me, is there a site where to test such a connection? If I have just one point?
So far, I've had 3 volunteers whip out on building that. I'm looking for another. This is a volunteer project. If you can deal with me. As the pointy-haired one, I'd love to have more people work on that. We've got a couple machines for this, but they haven't gotten used. Someone down here, Niels, and then Alan.
Can you configure it to have the S8 log for 8 hours or 1 hour of inactivity?
Not at the moment. I consider that a feature request. We have a website. I think we can go there relatively quickly. There we go. And on what? Oh, then you screw up my entire setup, John. Okay. On the website, there's a mail list. There's 2 lists that would really matter to you folks a lot. There's the users list and there's the design list. That should go to the design list, that particular request, because it's really focused. Yes?
Can you verify the text record is signed or not, if the DNSSEC is implemented?
All right. You'll be hearing a lot of weirdness from me over the next few years as I try to redesign the entire internet. I'm really literally serious. We started this process in the IETF of adding a new layer where no one realized we needed a layer before. And the reason I'm saying this is there's a problem. All of our APIs have to be thrown away. Every utility that has been written, even crap like XINetD that's trying to pretend to be secure, also has to be thrown out and rewritten. Okay, FTP has to die. When we do this, we have to add concepts of security to the APIs. All right, I have a lot of bad ideas about this. You can talk to me. The current situation is this. In the DNS resolvers, you can set up the resolvers to either return only pure, wholly checked results, okay, or none at all.
For zone basis or only for text record, on a record basis?
Damned if I know. And this is a real limitation, right? Because it means that there's no way to get a text record and to know if it was signed or not. So I have to be able to say, I only want signed text records. And if it's not in DNS this week, we'll make certain it's in DNS next week.
What would you do differently if it was signed or not signed?
Then don't communicate or go to the opportunistic encryption.
Right, if the answer is don't communicate, then just set your resolver for don't give me any unsecured results.
What John's saying is that you can set, we intend to have the system once it's in. Let me state something. I do not have this working with DNSSEC, right? It's next on my list when I get home. I have conferences and work keeping me away from home possibly until October. But when I next get at home and can sit at my lab, I'm going to make DNSSEC work, yeah, you're next, work with FreeSWAN, and I'll be able to answer these questions coherently. The reason I call this play opportunistic at the moment is that you're basically sucking text records, i.e. key records, out of the ether, and you're inhaling them no matter what they are. Carbon monoxide or weed, it just doesn't matter. Okay? This will have to be fixed. Sir?
Hi, just wondering, do you see opportunistic, it's opportunistic mode working well with ESP and gateway?
It is ESP. Okay.
How are the routes negotiated?
Okay, let's explain this. Opportunistic encryption is simply IPsec and IP. All right, it's the standard IPsec and IP. It's exactly the same IPsec and IP that you would use if you hand configured a tunnel with a pre-shared key or did an RSA key as part of your VPN or whatever. The difference is that we use DNS to get keying material that's RSA keying material that we then kick off the normal IPsec processing with. All right, so this is well-known tech, it's well understood. We interoperate with the same mechanisms with all sorts of people. It's just that we start the process off differently. That make sense? We should wrap up, but I have, oh, you, way over there.
What is the time frame on when would this be ready for, say, test run at night, fewer customers that will call the hotline if anything breaks down?
In all seriousness, let's go over here 3 windows. So that machine there has been up 46 days. The only reason it's been up 46 days, well, the power went out a day after I put the new kernel in it with FreeSpawn 1.91 in it, okay? And that machine's got 5 Ethernets, a T1, 2 serial ports talking PPP, and I haven't actually plugged in the USB modem yet, but you get the idea, right? It is to the point where you could set it in front of a web farm and start using it to filter traffic through, encrypted or non-encrypted, in a play fashion, right? Because we don't have DNS set. But, you know, it's looking to encrypt stuff for passive attacks. It's going to solve passive attacks. It just won't solve active attacks where somebody goes out and fakes your key record or your TXT key record in the DNS. Follow on, yes.
What is the overhead for the type of text implementation? What would it say in front of the web form?
Okay, let's talk about that. I have a few data points. Some of them are old, some of them are new. Okay, a 150 megahertz 586, my former test bits, will do 320 kbytes a second of triple DES encryption and not quite be pushed against the wall. Well, actually, no, that's pushed against the wall, excuse me. That's the entire CPU in use, all right? That is more than a T1 going full bore in both directions, okay? So if you could find a machine that old on the market, it would be more than a T1. An OC3, that's tough. Let me respond with, I have one user who's got over 500 machines in the field on cable modems that go through one box. Okay, admittedly it's a high-end box, but I think it's only in the range of 500 to 900 megahertz P3, right? And that works. The customer's happy, it stays up, it's reliable, and all the users are just happy as a clam. And that's a major research institution that's quite happy with it. 2 minutes. You, and then you.
So, DNSSEC may not be the final solution, but it's nice to add a green one.
Yes.
Is there any chance with the rootnet service to support it? Social engineering or at least those who are not located in the US?
I will state this publicly. ICANN has to go. We have to get rid of it. Last question.
We've seen in the talk before about the effect of denial of service attacks or denial of service attacks as well, and that they are indistinguishable from the Slashdot attack. So if you wanted to run Slashdot on such an IPsec box, what kind of an effect would that have? I mean, with millions of people reading that and the route tables that you see, then the all PSAs that Slashdot on that end we have to maintain. What kind of box do you think you're going to need for that?
My dream box. I can't tell you. In all honesty, that's engineering work that needs to be done. I would suggest trying it smaller and building up. It is obviously our goal that you can, let me finish up. The whole point here is that, at least in America, I believe that no one has a right to look over my shoulder and read what I'm reading unless they can convince a judge to sign a warrant and they knock politely at my door and say, we're serving this warrant to look over your shoulder. That's what this software is to prevent. Our goal is for it to be usable in the /dot context, so they can't know what you're interested in /dot in reading. They might know you're reading /dot, they don't know what you're reading. All right? That's where we want it to go. Please help us get there. Thank you very much.